quadratic equations. In this video, we're going to have an introduction to imaginary numbers with me, Catherine. So let's remember back a couple chapters. When we tried to take the square root of a negative number, we said that there's no real solution, or we put the empty set, or not a real number. Well, it's true, but now we're going to have some special numbers that we can put there. Not a real number is a special set of numbers called the imaginary numbers, which includes the imaginary unit we call I. Yep, that's pretty imaginary, isn't it? So what is an imaginary number? If I take the square root of -1, we would say there's no real solution or no real number. But actually, it equals I. That's the imaginary unit. So how exactly does that work? Well, the square root of -1 is the same thing as the square root of -1 times 1. Well, we could split that up into the square root of -1 times the square root of 1. Well, the square root of -1 is I times the square root of 1. And what's the square root of 1? Well, that's 1. So I times 1 is I. What if we have the square root of -5? Well, it's going to look the same. The square root of -1 times 5, which is the same thing as the square root of -1 times the square root of 5. The square root of -1 is I, our imaginary number or unit, times the square root of 5. Since the square root of 5 doesn't reduce, we would say I, the square root of 5. And I do want to let you know that the imaginary number is always going to go in front of the radical. So that's why we have I, the square root of 5. What about the square root of -16? We would have the square root of -1 times 16, which is the same thing as the square root of -1 times the square root of 16. Well, we know the square root of -1 is I, and the square root of 16 is 4. So our answer is going to be 4i. The imaginary number always goes behind an integer. All right, it's your turn. I'm going to have you pause the video, do these 3, and then press play to check. Let's see how you did. For A, we have the square root of -4. We could split that into the square root of -1 times 4. The square root of -1 is I times the square root of 4. Well, hopefully you remember that the square root of 4 is 2. So we end up with 2i. For the next one, negative square root of -9, you're going to notice that there's a negative in front of the square root. That's not going to change. It's still sitting there. That's why I put it in red. Inside the radical, we're going to have the square root of -1 times 9. Now this next one, don't get too confused. The negative red turns into -1. That's in red also. The square root of -1 is I times the square root of 9. And the square root of 9 is 3. Yeah. So we have -1 times I times 3, which is -3i. C, the square root of -8. Well, for this one, we'll have the square root of -1 times 8. Now we have I times the square root of 8. We always have to ask ourselves, can we break down the square root of 8? We can. That's the square root of 4 times 2. So we have I times 2 times the square root of 2, which is 2i, the square root of 2. Great! There are patterns of imaginary numbers, and this is going to be kind of cool. So first off, let's remember that the square root of -1 is I. That means I equals the square root of -1. Well, what's I squared? That's the same thing as saying the square root of -1 squared. Now there's two different ways we can think about this. We can think about it as the square root of -1 times -1, which is -1. Or we can think about it as the square root or the radical and the square cancel each other, which gives us -1. So I squared equals -1. So then what's I to the 4th? There actually are patterns to imaginary numbers. First thing we want to remind ourselves is the square root of -1 is I, and I is the same thing as the square root of -1. Then what is I squared? Well, that's the same thing as saying the square root of -1 squared. Now there's two different ways to think about it depending on how your instructor explains it. We could say that's the square root of -1 times -1, which is negative 1. Or the square root and a square actually cancel each other, which gives us negative 1. In either case, I squared equals negative 1. Let's look at I to the 4th. That's the same thing as the square root of negative 1 to the 4th. But what we're going to do is kind of sneaky. We're going to break up negative 1 to the 4th into negative 1 squared times negative 1 squared. Yeah, we're going to use some of our old exponent rules. When we break it up, the square root of negative 1 squared is negative 1, times the square root of negative 1 squared is negative 1, so that gives us 1. That means I to the 4th is 1. We're going to do the same thing for I to the 6th. So let's be sneaky again. Let's take negative 1 to the 4th times negative 1 to the 2nd. Hopefully you remember that when you multiply numbers with exponents that have the same base, in this case negative 1 is the same base, we just add their exponents. So that's why I could say negative 1 to the 4th times negative 1 to the 2nd. We break it up a little bit further and we see that the square root of negative 1 to the 4th is 1, because we just did it. And the square root of negative 1 squared is negative 1, because we just did it, which gives us negative 1. What do you think we could do with I to the 8th? This one, I did a sneaky thing again. I just broke it up into negative 1 to the 4th times negative 1 to the 4th. When we look back up, the square root of negative 1 to the 4th is the same thing as 1, and the square root of negative 1 to the 4th is the same thing as 1, so it turns out that I to the 8th is 1. I'd like you to pause the video, do I to the 10th using only things we know from this screen, and then press play to check. For this one, there's a lot of different ways we can add numbers to get 10. I decided to do negative 1 to the 6th times negative 1 to the 4th. You could have done negative 1 to the 8th times negative 1 to the 2nd. It doesn't matter because we're going to get the same answer. The one I did, negative 1 to the 6th, is negative 1. I should correctly say the square root of negative 1 to the 6th is negative 1. And the square root of negative 1 to the 4th is 1. So that gives us negative 1. You're going to notice that I did all even exponents. For the odd ones, it's not really that odd. We're going to be doing the same thing, but we're going to keep in mind that I to the squared is negative 1. This time, when I have I to the 3rd, I decided to split it up into the square root of negative 1 squared times negative 1 to the 1st. Well, we know that the square root of negative 1 squared is actually negative 1, and the square root of negative 1 is I. I to the 3rd is negative 1i, or we just say negative I. I to the 5th, well, let's be a little sneaky here too. I did the square root of negative 1 to the 4th times negative 1 to the 1st. When I look back at the square root of negative 1 to the 4th, that's 1. And the square root of negative 1 is I. That gives us I to the 5th is just I. Let's look at I to the 7th. I did it sneaky again. Do you notice I just did the square root of negative 1 to the 6th times negative 1 to the 1st? Yep, I just looked back at the last screen. The square root of negative 1 to the 6th is negative 1. The square root of negative 1 is I. Negative 1 times I is negative I. I to the 7th is negative I. All right, I'm going to have you try this one. I to the 9th. Pause the video, figure it out, and then press play to check. Let's see how you did. Well, were you as sneaky as me? I did the square root of negative 1 to the 8th times negative 1 to the 1st. Sure, you could have done the square root of negative 1 to the 7th times the square root of negative 1 to the 2nd, anything that adds to 9. But I find doing this is a little easier. Now I have the square root of negative 1 to the 8th, which turns out to be 1. And the square root of negative 1 is I. That gives us I to the 9th is I. Try 11, pause the video, and try my sneaky way. And then press play to check. All right, let's see how you did. Did you do it the sneaky way? The square root of negative 1 to the 10th times negative 1 to the 1st? Well, if we look back at our last screen, the square root of negative 1 to the 10th is negative 1. The square root of negative 1 is I. That gives us I to the 11th is negative I. Now, how cool is that? Here's two for you to practice. You're going to pause the video, simplify these, and then press play to check. All right, let's see what you did. Now, there are a lot of ways that you can split up the square root of negative 1 to the 25th. What I did is I used things that we already knew. So we already know what the square root of negative 1 to the 10th is. So what I did was I took the square root of negative 1 to the 10th times negative 1 to the 10th times negative 1 to the 5th. The square root of negative 1 to the 10th is negative 1. The square root of negative 1 to the 10th is negative 1. And the square root of negative 1 to the 5th is I. So guess what? I to the 25th is just I. Once again, I used things that we knew. Since we just did I to the 25th, I decided to take the square root of negative 1 to the 25th times negative 1 to the 25th times negative 1 to the 3rd. I mean, seriously, why should we make this super hard? The square root of negative 1 to the 25th we just figured out is I. And the square root of negative 1 to the 25th is I. And the square root of negative 1 to the 3rd is negative I. That gives us negative I to the 3rd. But here's the thing. When we do this, we either want a 1, negative 1, I, or negative I. What's the point of going from I to the 53rd just to another exponent, negative I to the 3rd? So let's look back here. I times I is I squared. So I rewrote it as I squared times negative 1. Well, I squared is negative 1. That means that negative 1 times negative I is I. So guess what? That means that I to the 53rd is I. Now that we have the exponents under control, let's do some multiplying and dividing with imaginary numbers. Let's look at the first one. The square root of 3 times the square root of negative 5. There's nothing we can do with the square root of 3. But the square root of negative 5 is the same thing as saying the square root of negative 1 times 5. Well, that will give us I times the square root of 5. Now let's put our square roots together. We'll have I times the square root of 3 times 5, which is 15. So our answer is I times the square root of 15. I know I can't reduce it any further because there's not a perfect square in 15. Let's look at our next one. The square root of negative 4 is the same thing as saying the square root of negative 1 times 4. And the square root of negative 25 is the same thing as saying the square root of negative 1 times 25. Well, the square root of negative 1 times 4 is the same thing as I times the square root of 4. And the same thing as the square root of negative 1 times 25 is I times the square root of 25. Hopefully we all know that the square root of 4 is 2. And the square root of 25 is 5. We still have to multiply them. So now we have 10 times I squared. We're not done yet because we just did this. What's I squared? Negative 1. So 10 times negative 1 is negative 10. That's our answer. And let's look at the last one. The square root of negative 2 is the same thing as the square root of negative 1 times 2. The square root of negative 32, the square root of negative 1 times 32. I hope this is getting into your brain because I seem to be saying a lot. Anyway, we're going to have I times the square root of 2 for the first one. But for the second one, the square root of negative 1 is I. But 32 actually has a perfect square, which is 16. That's why I wrote I times the square root of 16 times 2. The square root of 16 is 4. So now I have I times the square root of 2, that didn't change, times 4I the square root of 2. We're going to multiply these together. So I times 4I is 4I squared. The square root of 2 times the square root of 2 is the square root of 4. Well, the square root of 4 is 2, and I squared is negative 1. So 4 times negative 1 times 2 is negative 8. So our answer is negative 8. Let's look at dividing. Whenever we have a fraction, we want to figure out if we can reduce it. But in this case, negative 49 divided by 16 does not reduce. So what I like to do is rewrite it. So I'm going to have the square root of negative 1 times 49 over the square root of 16. The square root of negative 1 is I, the square root of 49 is 7, and the square root of 16 is 4. That gives us 7i over 4. Let's look at the next one. Even though it's not written as a fraction, we can actually rewrite it as a fraction. And in this case, when we divide negative 162 divided by 2, we get negative 81. So that's going to give us the square root of negative 1 times 81. The square root of negative 1 is I. The square root of 81 is 9, which gives us 9i. That's our answer. Let's look at the last one. Does 75 over 8 reduce? Nope. So what I did was I just rewrote it as the square root of negative 1 times 75 over the square root of 8. Even though we didn't do it in the last couple, I do have to break it down. I know the perfect square of 25 is in 75. So I rewrote the square root of negative 1 times 75 as the square root of negative 1 times 25 times 3. The square root of 8 also has a perfect square. That's why I rewrote it as the square root of 4 times 2. The square root of negative 1 is I, the square root of 25 is 5, and the square root of 3 is, well, just 3. On the bottom, the square root of 4 is 2, and the square root of 2 is, well, just the square root of 2. This is going to give us 5i, the square root of 3, over 2, the square root of 2. Now we have to think back for a second. Can we have a square root in the denominator? Nope. So what we have to do, hopefully you remember, is multiply by the denominator. So we're going to multiply by the square root of 2 over the square root of 2. That gives us 5i, the square root of 6, over 2 times 2. Where did I get this second 2 from? Well, the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is 2. That leaves us with 5i, the square root of 6, over 4. Now it's your turn to practice. You're going to pause the video, do these 4, and then press play to check. All right, let's see how you did. For a, the square root of negative 4 is the same thing as the square root of negative 1 times 4. The square root of negative 1 is I times the square root of 4. By now, you should remember that the square root of 4 is 2. So our answer is 2i. For b, negative, the square root of negative 9. The negative stays out front. Then we have the square root of negative 1 times 9. The negative in front is the same thing as negative 1. The square root of negative 1 is I, and then we have the square root of 9. Just like I said for the square root of 4, hopefully you remember that the square root of 9 is 3. Now we have negative 1 times I times 3, which gives us negative 3i. For c, the first thing you should have done is divide. That gives us the square root of negative 25. That gives us the square root of negative 1 times 25. The square root of negative 1 is I times the square root of 25. The square root of 25 is 5, so our answer is 5i. Let's look at c. For this one, negative 49 over 12 does not reduce. So all I did was just rewrite it. The square root of negative 1 times 49. And on the bottom, I wrote the square root of 4 times 3. 12 has a perfect square in it, which is 4, so that's why I rewrote it right away. The square root of negative 1 is I. The square root of 49 is 7. The square root of 4 is 2, and the square root of 3, well, it's just the square root of 3. That gives us 7i over 2 the square root of 3. But we can't have a radical in the denominator, so we're going to multiply the top and bottom by the square root of 3. This gives us 7i, the square root of 3, over 2 times 3. How did I get the 3 on the bottom? Well, the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. Simplify it one more time, and we end up with 7i, the square root of 3 over 6. Welcome to the self-quiz. You're going to pause the video, simplify, and then press play to check. Let's look at the first one, I to the 35th. It really doesn't matter how you rewrote it, but I decided to do the square root of negative 1 to the 25th times negative 1 to the 10th. The square root of negative 1 to the 25th is I. The square root of negative 1 to the 10th is negative 1, so that gives us negative I. The square root of negative 8 times the square root of 6. The first thing we want to do is reduce if we can. And I happen to know that the perfect square 4 is in 8. So I rewrote the square root of negative 8 as the square root of negative 1 times 4 times 2. There's not a perfect square in 6, so I just left it alone as the square root of 6. The square root of negative 1 is I. The square root of 4 is 2. The square root of 2 we just leave alone. And the square root of 6 we just leave alone. So now we're going to multiply. We have 2i the square root of 12. Hopefully the equal sign gives you a little hint that, yeah, there's a perfect square in 12. That happens to be 4. So now we have 2i times the square root of 4 times the square root of 3. The square root of 4 is 2. So our final answer is 4i the square root of 3. For the last one, I gave you a little bit of a hint. It doesn't matter if the negative is in the denominator or the numerator. That is, the bottom or the top, as long as you only have one. And it just seems easier to stick it into the top. I don't know, for me, it just seems easier. But you can leave it in the bottom if you want. It's okay. Then what I did was I looked at 28 and I said, well, the perfect square 4 is in 28. So I rewrote it as the square root of negative 1 times 4 times 7. And the bottom is just the square root of 25. The square root of negative 1 is I, the square root of 4 is 2, and then we have the square root of 7. In the denominator, the square root of 25 is 5. So now we end up with 2i, the square root of 7 over 5. Thanks for watching. The only way you're going to get really good at it is practice, practice, practice. And if you liked it, pin me to Pinterest. Until I see you again, thank you.